Hi, I'm Dr. CS, and in this lesson, we'll take a tour of Python. We'll create two versions of a program that prints a table of corresponding Fahrenheit and Celsius values. And along the way, we'll learn a lot of basic elements of Python programs. We'll learn about control structures, we'll learn about writing functions, and we'll learn how to create scripts that process command line arguments. Now, if you're a C programmer and you've read the classic textbook, The C Programming Language by Brian Kernighan and Dennis Ritchie, then you'll recognize this as one of the example programs from chapter 1 of that book. So to start off with, type the following code into your text editor or PyCharm and save it as Fahrenheit_Celsius_v1.py. And then run it and see what it does. Go ahead and pause the video and then come back. So the first thing to learn, and I hope you're looking at the program while you're watching this video, is the assignment statement. So in the very first line, we assign the value 0 to the variable lower. An assignment statement has the form variable and then an equal sign and then an expression. An expression as a sequence of symbols that has a value. We'll learn a lot more about that in the lesson on values and variables. 0 is just an int literal. That means it's the textual representation of an int value in Python source code. If we had a number with a decimal point after it, then that would be a float literal. So lower is a variable, and after the assignment statement, it exists. That's an important thing about Python. Variables don't exist until they're assigned values. So there's no declaration like there is in some other languages. It's important to note that Python is strongly typed. That means that you cannot create expressions. You can't evaluate expressions in Python that are not type consistent. But variables are dynamically typed, which means that types are not checked until runtime, and you can reassign a value to a variable of a different type at any point in the program. So print is a built-in function in Python. That means it's a function that is defined in the Python standard library, and you don't have to import it in order to use it. It's available at any point in any Python program. That's not 100% true. We'll see that it's possible to actually hide a built-in function by using the name, but that's generally a bad idea. But you can think of built-in functions as being available anywhere in a Python program. So in this function, we have the string print. That's the name of the function. After the name of the function, we put parentheses. And parentheses are the way that you call a function. In between the parentheses, we place the arguments to the function. In this example, we have a single argument to the print function, which is the literal string Fahrenheit space Celsius. Notice that the print function will automatically append a new line character after the argument that you supply to the print function. If you want not to have that new line character at the end, you can use a multi-parameter version of the print method and specify that the ending should be an empty string. That's what this part here means. And then we won't get a new line character at the end. While loops are a control structure in Python, and they have the form while. While is a keyword in Python. That means it has syntactic meaning to the Python interpreter itself. It's not defined in the standard library. It's actually part of the Python programming language. And after the while, you put a continuation condition. And a continuation condition is an expression that evaluates to a value which is either truthy or falsy. In the lesson on values and variables, we'll learn that a truthy value is a value that is not a 0 of a particular type. So for example, if it's an int expression, 1 is truthy, 2 is truthy, 0 is falsy. So 0 is falsy, all other values are truthy. An empty string is falsy, and all other string values are truthy. All right. There's also a Boolean type, which has the values true and false. And we'll learn about these in the lesson on values and variables. So this block, so after the header, so this while continuation condition is the header, and at the end of it, you have to have a colon. Okay? Now, Python does not use any sort of block start and end characters. It doesn't use curly braces like C-based languages like C, C++, Java, and so on. And it doesn't use begin and end like Pascal. It uses indentation. So the block, that is the sequence of statements and expressions that will be executed repeatedly as long as the continuation condition is true, that block must be indented one level beyond the while loop header. And this block is also called a suite in Python terminology. Now, we typically indent the block in Python 4 spaces. And that's specified, that 4 spaces is a convention that's specified in PEP 8. PEP stands for Python Enhancement Proposal, and PEP 8 is the style guide for Python. In other words, how you should format your source code. Another important thing to remember about these suites is that the indentation in a single Python source file has to use either tabs or spaces, but you can't use both. In many other languages, you can use both. And in Python 2, you could actually use both. But in Python 3 is very strict about it. You can either use spaces or tabs, but not both in the same file. And the convention is to use spaces, not tabs. So as an active review, let's look at this while loop that's part of our Fahrenheit Celsius version 1 and identify the components of the while loop. Line 1 here, this is the header. While, of course, is the keyword that introduces the while loop. This far less than or equal to upper is the continuation condition. So as long as that expression evaluates to a truthy value, and in this case it's a comparison operator, so it's going to evaluate to either true or false, an actual bool value, as long as that is true, then this body or suite is going to be executed. Now, the second question, why is the loop continuation condition guaranteed to become false over successive executions of the loop body? You can pause and think about it and then come back. So to answer this question, let's use PyCharm's help. So I'm going to go to my Python coursework project. And I've already entered these programs in, so I'm going to double click on Fahrenheit Celsius V1. And what I would like to do is run this in the debugger. So the question is, how do we know that this continuation condition eventually becomes false? It's very important that this becomes false because, as you remember from your CS1 or introductory programming course, if the continuation condition of a loop does not ever become false, then the loop never terminates. Well, to answer this question, so that means that far has to become greater than upper because the continuation condition is that it's less than or equal to upper. So to answer this question, let's use the debugger and step through it. So I'm going to do Alt F8. You can also just click in the margin here. If I click in the margin, it toggles the breakpoint. If I click it again, there's the breakpoint again. And then you can run this by Control-Shift-D. So Control-Shift-R runs the program, runs whatever program is in your editor, and Control-Shift-D runs it in debug mode. So if we run this in debug mode, As you remember from your CS1 course, it runs until it gets to the breakpoint. So while it's stopped, we can look at the values of different variables, and then we can step through the code. So there are many different ways you can step through the code. I like to step through the code by saying step into my code. That means that we will step into our own functions, but we won't step into standard library functions or built-in functions and things like that. All right, so if we do Shift Option F7, then that gives us the stepping behavior that we want. So we go to the next line. Celsius gets a value. So after we go through this line, we'll see Celsius show up down here. And there it is. The print statement, it just prints something, so we're not going to see any change there. And this is the important statement right here. Here we're updating far to be step greater than it was before, all right? Which means adding 20 to it. So we step through again and we get back up to the top. Notice that far is now 20, and so it's getting closer to upper. If we keep stepping through, we see that far keeps getting closer to 300. Now, at this point, far has the same value as upper. So when I step through this again, what do you think is going to happen? We enter the body of the loop again, because far is still less than or equal to upper. But now it's greater, and so when we step again, we exit the while loop, and since it's the last statement in the program, we exit the program. And then we finally get to see the output here. And finally, what happens if we change the continuation condition to be far less than upper? Well, we kind of already answered that when we stepped through. We saw that when far was equal to upper, we still executed the loop body one more time. If we changed it to be less than upper, then it would end when far is equal to upper, because then it wouldn't be less than upper anymore. F strings, or formatted strings. A couple of things first. So first of all, in this line right here, Celsius gets this value. That's often the way that we pronounce this. Celsius gets the value of the result of this expression. This expression produces a float value. The reason it produces a float value is because the single slash is floating point division. The double slash is integer floor division. We'll talk about that when we get to the lesson on values and variables. So Celsius then references a float value. That'll become important when we talk about this F string here. So an F string is just a string, so enclosed between quotes just like any other string, but with an F in front of the opening quote. And inside an F string, you can put expressions between curly braces, and then the values of those expressions are inserted into the string. So in this case, far is inserted into the string, and then we also have an additional format specifier after the colon. This particular one says the less than sign here means it's going to be left aligned, and this 10 means it's going to be in a 10 character wide field. Then we have a space. Then we have another expression that gets inserted. It's the value of Celsius. Now remember that Celsius is a floating point value. So our format string here specifies, so this says it's going to be right aligned. This says it's going to be a 7 character wide field. And this part here says format the value as a floating point value with one significant digit after the decimal point. And if we go back to our output, we see that that's exactly what we get. One significant digit after the decimal point. So if you'd like, you can go ahead and pause the video and experiment with different field widths, alignments, floating point precision, and so on. And you can learn more of these by following these links to the Python documentation for formatted strings and the mini language that specifies what goes in between, what goes after the colons in these expressions. So just as one example, let's say I change this to be a 2 instead of a 1. I'm going to do Shift Control R to run the program. Notice that it ignored the breakpoint because I'm not running it in debug mode. And we see here that now we have 2 significant digits after the decimal point. So version 1 of our Fahrenheit Celsius program was instructive, but parts of it were not idiomatic Python, or Pythonic as a Pythonista would say. And there are a few more constructs of Python we would like to learn in our tour. So what does idiomatic mean? So there are many cases where there's more than one way to do something in a programming language, and the way that it's normally done is the idiomatic way. An example of that, and we'll see that in a few minutes, is that if we are going through some range of values in a well-defined way, then we would normally use a range object to do that in a for loop rather than using a while loop. That's an example of a Pythonic way to do something. So pause the video here and take a moment to type this into your editor. Create a new file called Fahrenheit_Celsius_v2.py and enter these comments. And again, as I've said before, instead of just copying and pasting this, go ahead and type all of this in. So the code goes in through your eyes and then out through your fingers. Okay, so let's look at the structure of a Python program. Up at the top here, this is a fairly typical Python script. At the top, we've imported the sys module so that we can use it down here, sys.argv. We have some function definitions. We have 2 function definitions, and the function definitions are always going to come before they're used because Python is interpreted. So if we put the definition of Fahrenheit to Celsius below the definition of main, then inside the main function, we wouldn't be able to call it down here. All right, so definitions of things have to appear before they are used. We also will typically have a distinguished main function in a script. That's optional, but it's good style. It's good style for a number of reasons. One is it lets the reader know exactly where the script is supposed to start. It's also very similar to the way many other programming languages work, such as C, C++, and Java. And also, it gives you the opportunity to load a script into a REPL as if it were just any other module, and then you can test out this main function directly without having to run it as a script. You might find that useful sometimes. And we'll go over that in the lesson on modules and programs. Notice here that I have a comment. So the hash mark, or the octothorpe, the official name for that character, is the comment character in Python. So everything after that character on a line is ignored. So I could put that, after other code, and then the code will be executed, but everything after the hash mark will be ignored. And then down here, as we'll see in the lecture on modules and programs, this is sometimes called the if name equals main block, and it should be part of every Python script. It is essentially the entry point of our program. And you notice that it just does one thing. It calls our main function and passes the command line arguments. And we'll see the command line arguments in just a minute. Okay, so as we said, in order to use members of the sys module, first we have to import it. And once we do that, then this name sys, sys, is part of the namespace of our script. And so we can refer to members of the sys module by entering the name sys and the dot member selection operator, and then argv is just a member of the sys module. Also noticed that we called this file just like this file here. We gave it the name Fahrenheit _ Celsius v2 as the base name with an ending of .py. Now, technically, you can have a Python script in any text file. It can be named any way you want it, and then you can run it as a script. But in order for it to be used as a module, it has to end in py, and the base name, that's the start part before the .py, must be a valid Python identifier. We'll learn what a valid Python identifier is in the lecture on values and variables, but briefly, letters, numbers, and underscores, and the first character cannot be a number. Let's talk about functions. This is a function header. It starts with the keyword def, and then we have the name of the function, and then inside parentheses, we have a parameter list. And in Python, people often call it an argument list. Technically, it's a parameter list. And this is a formal parameter, has the name args. Now, this colon and type here is actually optional, but it's a good idea to always include type annotations in a Python program. For one thing, when I'm calling the main function, I know exactly what kind of thing I need to pass. I know what kind of thing args is expected to be. Now, the Python interpreter actually ignores these annotations. This is the annotated return value. It means that main doesn't return anything. But even though the Python interpreter ignores these type annotations, that's very good documentation to the programmer. And as I'll show you in a little bit, there's a program called MyPy that you can install with pip3 install MyPy, MYPY, which actually checks these type annotations. And so you can catch errors before you even run a Python script. Also note that this version of the list type with the lowercase l, which is exactly the same as the list constructor, is new in Python 3.9. So if you're using an older version of Python or you're looking at some code, you might see this list written with a capital L, and then that would need to be imported from the typing module. And even some of the code in this course you might see still has that capital L list. But we don't need that anymore. After Python 3.9, we can use the lowercase l. Now, once we have a function that's been defined, we call it somewhere else by saying the name of the function, and then parentheses. That's actually a call operator in Python. And then we put the list of arguments to the function in parentheses. All right. Now what happens is when we call main and pass sys.argv, sys.argv is actually a list, and it's the list of command line arguments that are provided to the Python program. When we call main, sys.argv, args becomes an alias for sys.argv. And we say that args is a formal parameter, and sys.argv is the actual parameter or argument to the main function. But like I said, in Python, people usually use argument to refer to both. So what are command line arguments? In general, command line arguments are extra strings of text separated from each other by spaces and or tabs that are passed to a program. In Python, command line arguments are captured in a variable called sys.argv, which has the type list of string, and it captures all of the command line arguments that are passed to the Python 3 program. So all of the things that I have highlighted here are collected into a list. So sys.argv has the value of this list here. Notice that the first element of that list is actually the name of the Python script. That's because sys.argv is a list of the arguments passed to the Python program, not to our script. So the first argument to our script is actually sys.argv sub1. In this case, it's the string 30. Also notice that all of these arguments are strings. All of these elements of sys.argv are strings. So if we wanted to use these as ints, for example, if we look at sys.argv sub1, which is 30, then we have to pass that value to the int constructor. What that does is the int constructor reads that string, and if that string contains the valid textual representation of an int value, then it returns that int value. Otherwise, it raises an exception, and we'll learn about exceptions in the lesson on control structures. So this statement right here, args sub1, passes it to the int constructor. This is an expression, and this returns an int value, and it gets assigned to the variable lower. All right, so now let's have an active review. You've typed in Fahrenheit Celsius V2. Now run it from your OS command line shell and experiment with different values for lower, upper, and step. Now notice you're going to have to run the script from an OS command line shell in order to provide command line arguments. Now technically you can create what's called a run configuration in PyCharm and provide command line arguments that way, but it's much more convenient to simply run it from an OS command line shell. And as I'll show you, you can actually do that from within PyCharm by opening up an OS command shell with Opt F12 on Mac OS or Alt F12 on Linux or Windows. However, if you followed my advice in the instructions on setting up IntelliJ or PyCharm, I recommend to bind Control F12 to the command open in terminal. And so that opens the terminal with the current working directory set to the directory of whatever file you have open in your editor. And I'll show you that as well. And then experiment with the command line arguments and see which combinations of these command line arguments you can leave out. For example, if you want to leave out lower, but just provide upper and step, can you do that? All right. So go ahead and pause the video and play around with your Fahrenheit Celsius V2 script, particularly with the command line arguments, and I'll see you in a minute. So here I have my Fahrenheit Celsius V2 script open. Now I'm going to open up a terminal with Control F12 because I've bound Control F12 to open in terminal, and you'll notice that even though Fahrenheit Celsius V2 is in my tour subdirectory, when I opened the terminal, it's already in the tour subdirectory, so I'm all ready to go. So now I can say Python 3, Fahrenheit Celsius V2, and I can give it different command line arguments like 0, start with 0, go to 100 with a step size of 10. And then we can see the different results. Also notice that just for demonstration purposes, I've added this extra line here that prints out the value of sys.argv. I'll go ahead and take that out because we don't really need it. Which of these values can we leave out? Well, if you look at the way we are reading these command line arguments, we can only leave them out from the right. Right? So the first command line argument that we provide here that goes to our script is only going to apply to lower. And then the second one, because we do these checks here, will apply to upper, and then the third one to step. So we can leave out the step, or we can leave out both step and other. So if I just say 0 here, then I'm going to go from 0 to 300 in steps of 20. Actually 0 to 280. And we'll talk about that later. Now, I also mentioned earlier MyPy. Now, notice here in my main function, args is specified to be a list of string. Now, the MyPy, so I've installed MyPy on my system. If I say MyPy Fahrenheit Celsius v2.py, it says no issues found. So everything is good. But if I pass something else to the main function, let's say I replace this with 1. It doesn't matter. 1 is an int. It is not a list of string. Now if I run MyPy, it's going to tell me that on line 25, right here, that the argument to the main has an incompatible type int. It should be a list of string. Now, I can still run this script, but I will get a runtime error. I get a runtime error on line 10. Now, this traceback, the way to read a traceback, and we'll talk about this a lot throughout the course, is to read it from the bottom up. All right? Because what it provides you is the call stack, the sequence of calls. Like, so we start with a call to main and pass the value 1. And then we go into main, and in main, on line 10, as it says right here, we encounter the error. So if we read from the bottom up, we zero in on where the actual error is. So this is telling us that an object of type int has no len. In other words, I passed an int. The type here is not checked when we pass it, because remember, Python is dynamically typed, and so we don't actually see any type errors until we use something. And passing a value is not a use per se, but the value is used here. And so we get the type error. All right. And then we can fix this. And that is the value of providing these type annotations and then using MyPy to check our program. Because if we annotate all the types and we get no errors from MyPy, then we can be reasonably sure that our program is going to run and at least not have any type errors. So moving on, if-else statements. So an if-else statement is pretty straightforward. It has this form, if, and then an if condition, which is an expression that evaluates to truthy or falsy, and an else clause. You can also have elif clauses, and when we do the lesson on control structures, we'll talk about those. But the most basic form is this. And the way this works is this expression is evaluated. If it's truthy, in other words, if the length of args is greater than 1, then the if suite is executed. And if it's not, if it's falsy, then the else suite is executed. We also have if-else expressions. Now, the if-else statement is a statement. So this altogether doesn't produce a value. It's a statements don't produce values, expressions do. So an if-else expression is a more convenient way to do what we did here. And I did it the two different ways just so we could see the two different kinds of if-else. Okay, so the if-else statement is a statement. It doesn't produce a value. The if-else expression, for a case like this where what you're actually doing is conditionally assigning a value to some variable, the if-else expression is more convenient for that. And it's pretty simple. Value 1 if condition, else value 2. If condition is truthy, the value of the if-else expression is value 1. If condition is falsy, then the value of value 2 is the value of the expression overall. So in this case here, this expression, the way it works is length of args greater than 2 is evaluated. And if args is greater than 2, it's truthy, and that means that at least 2 arguments were provided to our script because at least 3 arguments were provided to the Python 3 program. Then we know it's safe to subscript args with the value 2. And we do that, pass it to the end constructor, and then that's the value of the if-else expression. It's assigned to upper. If we don't have enough arguments, if this is falsy, that means that this will produce a runtime exception because 2 will be out of bounds. And this is also a way to guard against doing out-of-bound subscripting. And so if this evaluates to falsy, then the value of the expression is 300, and that's assigned to upper. And this is an idiomatic way to give upper a default value if you don't provide one at the command line. For statements. So first, let's talk about the range object. So what the range object does is it takes 3 integers, or up to 3 integers, in the most basic form, an initial value, an upper value, and a step. And then what it does is it iterates over the integers from lower up to upper, but not including upper, in steps of size step. So for example, range 0, 10, 2 would produce the values 0 to 8, or 0, 2, 4, 6, 8, right? So that's 0 plus 2, and then 2 plus 2, and then 4 plus 2, and so on. Notice that this upper limit is not included. All right, so range successively produces these values, and what a for statement does is it produces a loop where the loop variable, f in this case, gets the values generated by whatever iterator is supplied after n. In this case, we have a range object, which is an iterator that produces these successive integers, as I've just described. And in the first execution of the for loop body, f has the value lower. In the next iteration of the for loop body, f has the value lower plus step, and so on, until until we reach the last value in the range, all right, which we've already described here. All right, so as an active review, run your updated Fahrenheit Celsius V2 and notice what the last Fahrenheit value in the table is. Then think back to our first version of Fahrenheit Celsius V1, and answer the question, is our new version, is V2 a faithful refactoring of V1? So a refactoring means you change the internal design of the program without changing the behavior. And if it's not a faithful refactoring, in other words, if it behaves differently, how could we modify the new version to match the behavior of the original version? So go ahead and pause the video and then come back. Okay, so here I am in PyCharm again. I've got my Fahrenheit Celsius V2 open. Let's go ahead and run this with Control-Shift-R. I don't need to run this from a terminal because I don't need to provide command line arguments, because V1 of Fahrenheit Celsius doesn't take command line arguments, and so I want to run both of them without command line arguments. So if we run this, now remember the upper limit is 300, but notice that the last value is 280. Now, if I do V1, Control-Shift-R, notice that it goes all the way up to 300. Now, why is that? Because the loop continuation condition in the while loop is far less than or equal to upper. All right, so it only becomes false when the Fahrenheit value is greater than the upper limit. So we include the upper limit here. Now remember, so I'm going to do Command E for recently used files. And that's a quick way to switch back and forth between files. Now remember, in a range, the upper limit is actually not included in the range. All right, so you can think of the range, you can think of inside the range object, the iterator that it produces, there's a while loop, just like we had in Fahrenheit Celsius V1, except that this actually uses a less than sign instead of a less than or equal to sign. So the way we can get this to include our upper limit, what we've set as the upper limit here, is simply make this greater. And if we do that, the upper limit is included. We have just taken a whirlwind tour of the Python programming language. Now, when you are studying Python and as you go through this course, I really encourage you to look at the documentation. When you're learning any language, if you really want to master a programming languages, there are two things that you have to know. You need to know the language specification, and you need to know the standard library. So you need to have these links. These are all active links. You need to have all these links at the ready and refer to them often. All right, so the Python language reference is a reference for the language itself, but you might find the Python tutorial a little bit more pleasant coverage of the language because the references tend to be technical and sort of more for compiler implementers and stuff like that. And then this link is for the Python standard library. So back when I imported sys, for example, if you want to know what the sys module is, that's part of the standard library. And so you would find the documentation at this link. So in the remaining lessons, we'll dive deeper into everything that we just saw and a few more things. And at this point, if you are an experienced programmer, you're ready to start writing simple Python programs. And the first one to write, let's talk about the exercise for this lesson. Compounding table. So compounding table is going to be very similar to the Fahrenheit Celsius program we wrote. Basically, you're just going to write a table of the deposit amount given compounding interest, right? So the idea here is you make an initial deposit of some amount of money. That's the first argument to your script. And then you have a periodic interest rate, for example, 6%, and then you have some number of periods, all right? And when you have compounding interest rates, the amount you have on deposit is given by this formula here. The amount is the principal times the quantity 1 plus the rate raised to the power n, where P is the initial principal amount, R is the periodic interest rate, and N is the number of periods. So any one of these values could be calculated with this formula. All right, so pretty straightforward, very similar in structure to the Fahrenheit Celsius script. So have fun with this exercise, and I'll see you in the next lesson.